Of course, Kat. This is really necessary. Anyway, hello everyone, and welcome to another episode of What in the Name of Satan is this channel about? Well, so I've made this guitar, and well, first of all, the topic of this video is the sound, so I will jump straight into that. Then I will go about the actual construction of this thing, because it is actually quite interesting. Yeah, so I guess the little bit of context. Musicians be like, oh, this guitar is made of this wood and it has all this kind of characteristics to the sound. So, yeah, this is very great. So I was like, I wonder if I would made it out of metal, how it would sound. So that was like 10 years ago, 15 maybe. So I had a plan to make this. The body looked very different. The neck, I had no idea how I would make it, and I wasn't worried about hardware on the. What is this head? I don't know. I'm not a musician. Anyway, so yeah, and there was one jazz man, and he told me, oh, it would sound completely awful, and I was like, yeah, that's possible, but I want to know. So here it is. Anyway, so this will be my setup. This is the receiver for the UHF transmitter, and this is a effect that I have quite some time. It was stored away and not used for like 10 years. So it looks like it looks. Sorry for that. I guess you won't be looking at it anyway. Anyway, so I'm not going to play anything really, because I don't do that. I play along and stuff comes to my mind. I don't remember any melodies normally whatsoever. Anyway, so this is the clean sound of the guitar. And I guess you can notice that I'm plucking the strings quite far from the bridge, and this is the quirk of this guitar, I guess, because if I plug the strings at the position of pickup, the sound is quite flat, and if I do it at the bridge, it is ultra flat. So that's something interesting. Now this is a bit amplified because I'm using. There is some processing. Yeah, so I will be using this effect mostly, I guess. Will affect this sound. Don't know, this was some chords, some higher. And I guess individual strings, I guess. Let's do power chord, which I do like 90% of the time. I don't really hear any overtones that are like harsh, so, and it is like evident in the when I use distortion, like. One other thing is, okay, so the distortion sounds okay, but when you like play with muted strings, the sustain is like insanely high, so I have to move my hand almost to the pickup to like do like more aggressive like muted strings, I guess. What is interesting with clean sound, if you do this and like mute the strings, again, sustain is insane, but there is quite weird like phase shifting almost, like, so this is that is like quite weird actually, how the sound from the body translates to the pickups, and like this is my favorite. This is absolutely the best thing ever. Anyway, yeah. Oh yeah, and one thing also. Now the thing about the overtones, I guess, if you slide around on the neck, these overtones are quite harsh and sustained, but I guess you can like leverage it back, like doing this, for example. So this is one thing that this thing does, I guess. Not sure, probably wooden guitar would do this as well, but this is nicely accessible. Well, anyway, I wouldn't be able to tell you if I like this thing or not, because I did not play normal guitar for like 10 years, so... Like 3 years ago I had a wooden electric guitar and I was like, okay, let's try this. So I started with the neck, obviously, because, well, not obviously, but it is like something that I did not have in head how I would approach. So obvious choice for me was aluminium, because it's easy to cut and well, it's metal, so it's fine. But you see, the wooden guitars have a pre-tensioning bolts in them, so the question about this is the strength of the neck. And well, anyway, so you see, at this point my memory is not working correctly. I mean, it was a long time ago when I was thinking about these things, but I have chosen 40 by 15 millimeter aluminum profile, and I have the theory that it would be relatively ergonomical to hold because it is so slim. But because it is so slim, it is not as strong, and so I did test it quickly on the wooden guitar, and I said to myself, yeah, this is fine, I can work with this. So the neck is basically done, so... But I quickly realized that there's a little problem. You see, normal guitars do have a taper on the neck, and so the width of the neck here is smaller than here, and which means that here you have this is one coil of a pickup, but you can see that, can you see? So as you can see, the holes in the pickup for the cores do not line up with the strings, and quite significantly so. So what do? So I bought a good quality pickups, so I can like look how they are constructed, and that was probably unnecessary, probably very cheap one would work, because it is very simple. There is just a magnet and some two steel, well, pieces that conduct magnetic field, and the cores. So here I used some bolts as a cores. Anyways, we will get to the pickup soon. Oh yeah, and the head. Well, the thing is that I did not want to use classical like tuning mechanism, so I wanted to make my own, and this is a thing that I also was like experimenting with in the past a little bit. So this works. Let me. Originally, this was constructed completely differently. So I had a hole for the string, and there was a hole for the screw, and you know what? I probably cannot explain it like this. Listen, I will try my best to explain the original idea. So this block is the same thing as this one. It's just something to hold a set screw, and this is a block that has like 3 holes in it. This one is for the set screw with thread. This is little hole for the string, and this is a screw to hold the string. So the string would go like from here, and you wrap it around the screw and tighten the screw, and that would be the way how to secure the string. The problem was material, because I have done this from steel, which rusted away after a while, and I was like, I would like this hardware to be made from brass, because I thought that it would look nice, and brass is fine, brass is good material. So this is easy to get from steel, but I could not get it in brass. So I'm not sure where you can see it best, probably here. So how it works now is there is a mild interference in the string, which is wrapped here, and then it is wrapped a lot around these 2 pins, and then just it goes away. And this holds absolutely perfectly. So here at the thickest string you can see that the string is almost coming out of the pin, but this holds fairly well. Where there actually is a problem is on the thinnest string, because I have to make a loop of... I had to loop it under the thing to fix it to itself. Basically the bending radius here is so high that this does not want to retain its shape, because this is so flexible that it does not want to hold there. Because I have accidentally made position of these 2 screws incorrectly. I assumed that this would be spaced equally, and this lobe, I guess I could call it, is also longer, because I wouldn't be able to fit this block here. And this all works fairly well. I can remove the string just like this, and it is free basically. And I will be removing the strings with these blocks attached, because I don't need to undo this. Oh yeah, also the force of this is so small that I can do this basically one-handed, and yeah, and it is in tune. This is super quick. The only problem is that I am using a tool for this. I would make something out of steel probably, but I don't have a lathe at this point, so I kinda regret that I did this lobe in this way, but it's too late. So this is this whole thing is made out of 4mm of stainless steel. These parts are laser cut, by the way, so this wasn't very hard to make for me. I just paid. It is not super nice how it is attached, because right now there are some 2 spacers down here that holds this in place basically, and the problem is I could have used a different size of spacer, and I wouldn't have this problem probably. And also the neck was cut because originally I planned to have some block attached here to... what is this called? It is called nut? Yeah, this is called nut, I think, to hold a nut, but I quickly realized that, well, actually I need to do this differently, so I have used a sheet of brass and just cut some notches into that to hold this in place. But the thing is, I need there to be some downward force on the strings, so originally I would cut this aluminum neck somewhere around here, but it is fine like so, but I had to add this thing that pushes the strings down, basically. Originally I wanted to rely on these screws, for their head to push the strings down, but yeah, that did not happen, as you can see. Wait, focus. Also, these strings are attached to the body by few notches here, like this. This is cut on the laser, so it holds there, and then I basically grab these and I just pull them out. Something that I was thinking about last minute is the bridge, because this was not easy. This is already super low profile, and it was not easy to make this. So you can see this is like this is 6mm high, and so what I did was I got these hex distance spacers and I soldered on a bit of brass rods. These are 2mm, these are I think 6mm. So the height in total of this is 8mm. Then it goes down to the 6mm, and then it goes down quite sharp angle. The angle from here to here is not very great, and overall this solution isn't nice. And still, the thing is that I set this to the position that I calculated from CAD to 10mm from here, I think. Yeah, so 10mm from here, and the strings are in tune relatively on their whole range. So I am thinking that I will ditch this whole bridge completely, and instead of that I will use just L profile like this. I will shorten it a little bit and somehow make it so it screws here and it captures the strings here. And the idea behind that is also to lower the strings even more, because, well, I remove the strings, so it's hard to show you, but the distance from the string to the pickup first of all, and then to neck, I have I think like the strings are like 4mm above neck, which is not great. And it is not great for two things, because first of all it is hard. First of all, it is not easy to play, at least not as much as it could be. And second of all, it is producing a bending moment on this neck, which causes bending, obviously, which increases the height of the strings above the neck even more. Now, to better show you how this thing holds in place, I have to remove the electronics bay, which is located right here. There is a wireless transmitter and stuff like that. This electronics bay is a bit of a afterthought, and therefore the holes are drilled by hand, so some screws are a little bit more tighter than they could have been, I guess. But these spacers are basically designed to also keep this these two plates together, because there are also two holes right here where I plan to have a spacer, and this is also for a belt, which I don't use, but I mean it is there, so you know. There's lots of screw here. Originally I wanted to have countersunk screws because reasons, but I decided to not do that, because this is stainless steel and it is not easy to cut these, and these are fine. These are not like not doing like anything bad. Where is it holding? Here's one more screw. Alright, so this is electronics. The pickup is connected by this very not great connector here, which is, I just used what I had and that's about it. And I will discuss this later, because there is some good things, but not relevant for now. So now I will remove front panel, and this way you could see a bit better like all the hardware that is here. Alright, so the front panel just lifts up like this, and you can see that the bridge is attached to it like so. It is just 2 holes. These are also laser cut, which anyway, it's fine, but yeah, this is about it, and there's nothing else here. And here you can see how the neck is attached. Also, these 2 spacers are all basically that is keeping these 2 plates apart. And the neck is cut in a very special way because, well, so here you can see a spacer below the neck. The spacer is basically just 2 pieces of aluminium. It holds by 6 screws, should be plenty, and I had a little bit of issue with this neck bending a bit too much, which is not what I experienced when I first tested this concept, but I tried to fix it by adding aluminium profile, which you can see in the center, and it did help quite a bit, but I want to replace it with this one, because not that it will help much, but this was like 1.5 millimeter wall thickness and I wanted 2 millimeters, and the bad thing about such wall thickness is that it is hard to make threads into it. So one screw has a nut because it does not hold there by itself, which is not good. And when I tried to make the connection of this reinforcement profile, I guess, with the neck, I tried to bend the neck in the opposite direction and drill the holes, but it did not work very well. I tried to do some pretensioning basically, but yeah. And the way how the neck is attached to the thing is also a little bit of afterthought. In the CAD I planned to have a much higher position of the neck against the front panel, but I have decided that it does not look as well as it could. Alright, so here you can see the spacer, I guess, and these screws are holding the pretension, well, reinforcement bar. It's not doing very much pretensioning, I guess. Now I need to give a little bit of advice. So normally when you make a wooden guitar, you press these frets in, and obviously, well, not really obviously, but especially with hollow aluminium profile like this, you won't. Trust me, it wouldn't work. So I glued this with CA glue and it works. You can remove it with acetone fairly easily, so that works fairly well. Next thing is, I have bought a bunch of stuff. I thought that I will try a few. These are higher profile than these and thicker, and I have decided to not use these, which it could work. It could work, but the thing is that I play black metal, so I do a lot of this, and because these must be rounded, at least on the bottom side, and I think these are insufficiently rounded, so it can be painful. Another thing, try to buy these with as thin. What is this? This part of the thread? Is it stem? I guess. Try to buy it with as thin stem as possible, because basically what you want ideally is so much wiggle room so you can make sure these are perpendicular, like absolutely perpendicular, and I don't think you can make this position, like you can't do this after you make the slot, but at least the perpendicularity and well, try to be as precise as possible. If you can avoid doing this by hand, don't. The handsaw has some thickness to it, like I think mine has like 1 millimeter, maybe 1.2 or 1.5 even, and so it must be fairly snug for CA glue to like hold it, and but you have to leave yourself some wiggle room if you cannot do precisely perpendicular slot, which is hard with hand tools. So, and another thing which I haven't done yet, and I haven't answered for you what will work, but this is aluminium. Aluminium will leave some residue on your hands, so you can maybe see after you're playing for like hour or two, your hands are black. So the neck should be anodized, ideally. Alright, so I guess let's look at the pickup. Originally I did not want to disassemble this. So here you can see how it is constructed. There is a basically two forms where I wound bunch of wire. I'm not exactly sure how much turns, like probably in tens of thousands of turns, and this is 0.05 millimeter wire, I think. And then there are two wooden spacers, and these are also, I guess I glued the coils to the wood. And then there is a magnet. This I think I can remove. Yeah, I can remove it. And this magnet is polarized such that north and south pole is parallel with this plane. And then there are these two steel blocks or profiles that are just to conduct like the magnetic field, and these are drilled out. These screws are then screwed in, and this way also you can set the height of the thing where you want these ones, for example, to be more sensitive. These ones are a little bit higher than the rest, but yeah. Now this is a little bit of also advice, I guess. This is 0.05 millimeter wire. It is about thickness of human hair. So to make it not break, you have two options basically. You have like some kind of epoxy or something like that, silicone, or I have used wax, which is really old school, but still, in order for this to not break, you have to make some kind of, you have to reinforce the end of the wire, pretty much. So the way I did that, so imagine that this is the copper wire. So what I have done is I have made few loops like this, basically maybe one, maybe two, maybe three, and then I grab this and I twist it. And this way you have thicker wire, and because this is, again, this is about thickness of human hair with the enamel, so imagine how thin the copper is. And this matters also because when you try to solder it, the solder can dissolve the copper, so with this trick you can solder it just fine. There is again like risk where you have transitioned from thick to thin. It is more prone to failure by breaking, basically, like brittle failure. But as long as you use some kind of coating to like do the thing, you can avoid that. These are connected in series, and most pickups are probably wound in series or connected in series. And you may have noticed this terminal, it is for grounding, and while humbuckers are supposed to like prevent hum, but yeah, not really. And also because this guitar is made out of metal, I can tell you that this is probably the quietest guitar I have ever heard. So, I mean, it hums the least of all of them. So this is connected just like this, and again no shielded cables because the whole guitar is shielded. Anyway, so what's here really? Not much. There is a battery, there is a transmitter, there is a preamp because of things that I will mention later, and there is a pass-through guitar jack. This is for charging the battery, and this is used only for push button. Okay, so let's jump straight into the transmitter and receiver, I guess. It is this one. It is WTF AR01. It is mostly fine. Would I buy it again? Absolutely yes. This was also afterthought, and so I bought this thing, and I was like, okay, let's open it. So I gutted the thing, and this is what's inside. So I was like, okay, well, how am I going to integrate it into the body? And there's a lot of stuff here. So I 3D printed this enclosure. It is copying the contour of the body pretty much, but the important thing is antenna, because this is steel, so I have opted out to have antenna here, and this is because originally it was routed, or it was in this like space, as you can see, like it is soldered on that very piece of PCB, and it was inwards, so I just flipped it around, and this works. And again, related to the transmitter, the thing is, you want basically three things. First, antenna. Second of all, you need to be able to turn it on, which could be problematic. I mean, I could have drilled the hole here and make a push button with thing and make this better supported here, because now it is just glued here with a bit of hot melt glue gun. But I've opted out to disassemble the push button and just use contact here to basically turn it on. And well, actually there's another thing, kinda sorta. Well, the op-amp, because where are you going to get power to the op-amp? Because ideally it would be stabilized, it would be filtered. You don't really want powering this from the battery directly, because just look at YouTube, maybe how noisy the batteries are, because you would be surprised. I definitely was. So I found some regulator on the other side, 3 volts or something like that. Yeah, I was like, yeah, this would work for me. The op-amps obviously are very low voltage ones, rail to rail, and anyway, here is the audio input. There are pads for it, so that's really nice. It's high impedance, as you would expect in electronics these days. So originally I did not have this preamp, but I was like, you know what, the sustain is not very good with this thing, with this setup, and I was like, I don't know, I just put some preamp there, and what would be good, 6 decibel gain, yeah, sounds fine. So I made the thing, and then it worked. Later I connected it to the oscilloscope to compare like signal, like levels and distortion and delay. And actually I found out that the 6 decibels is pretty much perfect correction for what this would lose, or what this would lose. Yeah, so you can see this is the rail to the preamp, and this is some regulator there. This is the transmitter chip. It's some made in China stuff. It has a name, you can buy these chips. The datasheets I found is just in Chinese. This is some no-name microcontroller. And anyway, these chips are designed to be used with wireless microphones. So there are, these pads here are I2C or I2C, so you can throw that no-name chip and bypass it basically, or hijack the thing for whatever you would configure it as, because you can configure a bunch of stuff there. You You can do some simple audio processing, you can choose at what channel it operates and stuff like that. So I was looking for chips like this because I would like to have like wireless headphones as well. But surprise, surprise, I have not found any Western equivalents really. So you can see here there is this USB-C extension cable. It goes here, and I have routed it here so I can charge this thing. And the preamp setup is relatively simple. This is the pickup, obviously, and this is just bypass to the jack. And technically I have kept high impedance here. This is like voltage divider, so I can have some signal offset from the like if this is the like graph, I want to have signal like this, not like this crossing the zero line, obviously, because I have a non-symmetrical power supply for this, only 3 volts, so not much to spare really. So this is tuned to 0.5 volts because I have measured the signal coming out of the pickup with oscilloscope, but it is like 140 millivolts peak pretty much, so that should work fine really. This is just a unity gain, and this goes straight to the other op-amp which has this 6 decibel gain, so 2 times. So I should get 1 volt plus signal, so 1.28, 1.3 volts peak should be there. Possibly higher, possibly lower, and then just decoupled by capacitors so I don't get DC straight into the transmitter, but probably it could handle that as well. I mean, it's high impedance, so we would assume that there would be some decoupling there as well. I mean, not that it's necessary, but anyway. One thing worth noting is that this thing is transmitting about at this frequency. I can receive the signal on normal radio, so this is just wide frequency modulated thing. You can see how wide this channel is, pretty much 200 kilohertz, this is insane. But anyway, so I have trouble picking the signal on a straight antenna like this, so this is probably circularly polarized antenna, which, what was the frequency? Yeah, 700 megahertz at this antenna. I guess this is like, I mean, even if this was quarter wave, but this is so tightly wound, I don't quite see how this is circularly polarized, but I don't know, I'm not into radio magic, so I don't know about this. If you have fairly low impedance signal and plug it straight here, you can pretty much transmit the thing, so the pickup is probably like few hundred kiloohms, I don't know. Let's measure it, I guess. Holy shit, 12 kiloohms. Yeah, so now you can calculate how much wire do you need for the pickup. Anyway, so I think I've covered everything really that I wanted, so I guess see you in the next one.